All right. Test tomorrow. I need to focus up. I've been studying lessons since 2 a.m. Now I need to study today, probably till 11 or so. Because tomorrow I'm going to have to ask a question in my programming class. But yeah. Right now I need to focus up on proofs. I'm going to be doing that. I already finished the first question. And so far, where is it? I'm on. Did I do that? I'm on question 2 actually. The hardest thing for proofs right now, I would say, is bi-directional proofs because you have to prove both the front end and then the back end. The back end is a contraposition of it's like basically the contraposition of a basic like if and only if statement. So you have to prove both the front end and then prove the back end. The back end is an indirect proof. So basically everything um is in a negation. That's kind of what a bidirectional proof is. So let's say, let's suppose that, let's see, I'm trying to think of a good problem. Not this one. This one's actually really hard. I still don't, um, I was in my professor's office hours, so question 10, and I still was just like, because he didn't really help me out. There's so many people um, in a math learning center, or I guess in a math department. I was like I was sitting in the study area or like the practice area for math problems. Professors go in and out and help out. There's only one professor there, and it was mine. And he couldn't really help me out a whole lot for this problem. He just basically wrote down a whiteboard, or I guess on a window, and was like, "Hey, blah 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 blah," and said a bunch of random shit. And he didn't really help me out all that much. But I can do this problem. So suppose that let n be an integer, prove that n is even if and only if, and 7n squared minus 4n plus 3 is odd. So first things first is you're going to prove that n is even, and then after that you're going to prove that n is odd, and you're going to see which one is if and only if 7n squared minus 4n plus 3 is odd. And if it's n is even, then the proof is correct. It's kind of like that, and it gets very complicated very, very, very quickly, and it's kind of the hardest part isn't really the math itself, it's, explaining. It's the English part that's in particular difficult for, proofs in general. You have to be very peculiar with, or very particular with, the way you're actually writing, the way you're actually explaining the proof. Because if you say one thing wrong, the entire question is wrong because you're not proving that, you're assuming, and that isn't. There's a very big difference in assuming and proving. You can't have any assumptions and proofs because that inherently means it's not a proof. You're making an assumption. You're trying to prove that this answer is correct with all reasonable, with with no doubt whatsoever. You should be able to literally show this to somebody and they can say that's correct, that's true. That's kind of the whole gist of what a proof is. And you might be thinking in your head that's easy, and you could say that. In my opinion, direct proofs are they're very straightforward because it's direct. But then you start getting into nitty gritty of bidirectional proofs, and that's when it gets pretty difficult. And indirect proofs is you're proving the opposite in a way. But yeah, that's kind of it. So it's going to continue. And as I'm like talking right now, I'm like, oh my gosh, did I forget something in this? I don't think I did. That's the reason why I practice. Is because that's the reason why you can't really practice the night before. Because if you only practice the night before, like obviously I am practicing the night before, but what I mean is I didn't start practicing the night before. I've been practicing math problems or I've been studying for the test since Friday. Or actually, technically Thursdays because Thursdays when I did my proof math homework or for chapter 3, which I'm on right now. So technically Thursday, then on Friday I started to kind of review the previous chapters, redid the homework, and I've been doing that still today, just redoing the homework, trying to retain everything that I learned the first couple chapters in my head. The main thing I'm kind of focusing on is proofs because that's the most recent topic that we really did, and I don't understand it completely. Now I'm starting to understand it. Now I can somewhat explain what I'm doing. What helps me remember it is kind of streaming, so I can kind of talk through the problems, and that's kind of what I'm going to continue doing throughout. Um, I would say throughout my years of doing this. But yeah, let's go ahead and start doing this. Let's knock out a couple problems. Might have to go back to my homework. I hate going back to my homework because that means homework is a crutch. I shouldn't have to go back to it because that means I don't completely understand what I'm doing. Okay, let's do this. All right. So, already wrote down basically entire problem for 3.2 or question 2. So let n be an integer. Prove that if n is odd, then 2n squared plus 9 plus 1. I mean 9n plus 1 is even. So first, we're going to say let n be an integer that is odd. The reason why we're saying that is because we're trying to prove that n is odd. This is a direct proof. After you say that, we're going to say that there exists an integer k such that n equals 2k plus 1. Now, the reason why we say there exists an integer k such that n equals 2k plus 1 is because we're basically we're trying to we're like we're unpacking the definition of what is an odd number. That's kind of the reason why we're doing this. We're trying to we're not adding any examples. If you add proofs, you're explaining what is on. You're basically explaining what is the theorem, what is the problem. For question 2, it says let n be an integer. Prove that if n is odd, then 2n squared plus 9n plus 1 is even. That is the problem. We're not adding an example to the problem. Adding an example to a problem inherently means that's not a proof. That means that it's, in blatant terms, that means it's not correct. The answer is not correct. Or that whatever we're doing is not correct. We're not trying to add anything onto the problem. So there exists an integer k such that n equals 2k plus 1. That is unpacking the definition. After we do that, we're going to do 2n squared plus 1 plus 1, 9n plus 1 equals 2 parentheses 2k plus 1 squared plus 9 parentheses 2k plus 1 and parentheses plus 1. After that, we're just going to do a basic math problem. That's going to be 8k squared plus 8k plus 1 plus 18k plus 9 plus 1. After doing that, 8k squared plus 19, 20, 21, 22, 23, 24, 25, 26, 26k plus 11. That's odd. So the proof is correct. But after you do that, after you write down your problem, or write down what it is when an odd number is in 2n squared plus 9n plus 1, you can say, wait, I might mess something up here. $18 plus 9 plus 110. Did I mess something up? Let me double check. Let's see, 2k, that's 4k squared plus 2k plus, that's 4k squared, that's 2k, that's 2k, that's 1. After you do that, it's going to be 4k squared plus 4k plus 1, that's 8, k squared, that's 8k, that's plus 2. I knew something was wrong because I was like, what? How did I make that mistake? It's very stupid of me. That's 12, which is even. Which is even. So you basically, after this, you want to restate. Which is even. After that, basically restate what you're trying to prove. So put so if n is odd, comma, then 2n squared plus 9n plus 1 is even. After that, you did question 2. Direct proofs in general are pretty straightforward. You're proving the front end, or you're proving, you're basically just reading directly what's on, you're basically reading the question itself, and you don't have to really change anything. It starts getting pretty complicated, in my opinion. Not just some bidirectional proofs, but also indirect proofs can also be really complicated. Whoops. For me personally, I'm still probably gonna have to go back and reference my homework again in order to make sure I'm actually doing it correctly. But direct proofs, I pretty much already understand the method of what I have to do now and what I need to write down. And direct proofs, I know what to do. It's just the beginning. I'm struggling to remember. I don't know if I need to restate what I'm doing. I know I have to for the bi-directional proof, so I have to. Let's menu 3.3. Prove. Whoops, not proven. Prove that if 8 divides n, then 4 divides 6n squared plus 5n plus 12. So for this, what you're going to do is if 8 is divisible by n, so what we're going to do is, wait, let me double check this. No, we don't do that. Let n be divisible by 8. That's what I need to write down. Or let 8 be divisible by n. We're going to do let 8 be divisible by n. Let's 8 be divisible by n. There exists an integer k such that, let me double check this. See what I mean? It's because it's the divisible part that is making me kind of struggle in a weird way. On my screen, I think they're saying something in the chat. Alright. Let me just double check this, guys. I apologize. Not that one. This one, yeah. let n be an integer that's divisible by 3. Alright, so I was initially correct what I said beforehand. Why did I make this mistake, man? Let n be an integer that's divisible by 8. Durr. Come on now, Ethan. It's divisible, not fucking divides. Alright. Alright. It's my first mistake. I'm kind of pissed at myself for that. Let n be divisible by 8. Let n be divisible by 8. After I write that down, there exists. And let n be an integer. I can write that as well, but n that could also work, but let's be more specific. Or specific, not pick. Let n be an integer. That is divisible by 8. After that, there exists an integer k such that integer. You could write anything. You can write anything. You don't just have to write k, as long as it isn't the same exact letter that is already being used, such as n in this case. You can use k. You can use k, m. You could use y. You can use z. You can use e. You can use anything. But there exists an integer k such that n equals 2k. Then after that, put a comma and write down your problem. 6n squared plus 5n plus 12 equals 6, parentheses, 2k, and parentheses, to the power of 2 plus 5, 2k, and parentheses plus 12. After that, simple math. You would think it's simple, but even I mess up because I'm a fucking idiot, but yeah. This 10k plus 12. 6, 12, 18, 24. This is 24k squared. Plus 10k plus 12. After that, it says prove that if 8 divides n. Oh, I know what I messed up. Right? Wait. I know what I messed up on. How am I making these mistakes right now? Oh shit. It's because I didn't get enough sleep today. I'd stay up pretty late studying math. Or practicing math. I apologize. I wrote 2k when I shouldn't write 2k. I'm supposed to write 8k. Because it's saying divisible by divides 8. Or it's a complete opposite of dividing and multiplying. So it's going to be 8k. Duh, come on now. I apologize, guys. 6 times 8 is 48, right? It's 36, 42, 48, yeah. 48. Plus 40k plus 12. Now we're grooving right now. After writing all this down, go ahead and do, let's see, it says, then divides. After that, do 4. It's going to be 12 squared plus 10k plus 3. It works. Which is You don't say which is even because I'm not trying to prove this even problem. We're proving that 8 divides n, which 8 divides n. So if 8 divides n, then 4 divides 6n squared plus 5n plus 12. Let me double check this. I can actually get it. Okay. It's always these problems, man, I swear. Worksheets, direct proofs.
Something in an integer m or k or whatever you want to call it, as long as squared minus 4n is equal to 2 times 5m squared minus 4 times 5m. 5m squared is 25 is 50. 4 times 5 is 20 by 10.
Which is divisible by 10. So I'm still proving then if 8 divides 10. So if,
Therefore,
therefore.
if 5 divides n, then
Okay. That's easy as pie. I can easily do that. Sorry, I always have to double check right now. I don't know why. Which 4 divides, or I could write which no, I could do this. Which 4 divides I can do that. Let me double check. What did he do? Which is divisible by 10. Did that. You just did the classic. Okay. I'm gonna do what he does because at least I'll know it's right. I don't know why. I easily understood this like last night. Good thing I'm doing this, which is divisible by 4. Therefore, comma, if 8 divides n, then 4 divides 6n squared plus 5n plus 12 and parentheses, period. I need to go to the bathroom. Be right back.